The last component of direct cost estimation is the contribution of equipment and resources that go into our unit cost dollar per part. So that's what we'll look at today. And also, how do we deal with the indirect and overhead costs? Where do they factor in? So if we look at resources, again, because it is a direct cost, we have to be using these resources directly in the manufacturing processes during the adding of value. And so we have a useful life in which this equipment is usable to produce that value. We can further categorize it in terms of a recurring cost. Typically, the time frame for that is some type of annual cost versus a non-recurring cost. The big difference here is if it's non-recurring, then I need some finite time horizon. If this is time, at some point, we're going to have to replace that particular resource. Versus when it's recurring, and we should also note that when it is recurring, it could recur multiple times during the year, but we're just going to look at it as an annual cost. So whatever this time horizon is for non-recurring, 10 years, 7 years, it gives us a window of production. So if I look at N sub I, the production we are achieving each year, that gives me an idea as to how to spread that cost out, similar to what we did with the bonus in direct labor. The non-recurring costs are essentially a one-time cost during that time horizon. Usually it's a significant capital investment, such as a piece of machinery, CNC mill, a press, something that's significant. We also have a maintenance cost over that time horizon, and as we just indicated, the cost will be spread out over all future production volume. Now, this should be of concern because, similar to the bonus, there's a great deal of uncertainty as to what that future will hold. And so we definitely have to consider sensitivity analysis, because the further we go out into the future, if we're predicting a certain level of production going out into the future, it will probably be fairly uncertain. So we put kind of an interval around that of possibilities, and that cost is somewhere in that range. Well, as you saw in engineering economy, we can annualize the investment and divide by the production volume. So examples might be equipment, fixtures, other items that again have a significant investment. A die set that costs us $500,000, we're not going to replace it often. It will be an infrequent purchase. So the parameters we'll use here are production volume that we saw before, but now we'll index it on the year, because we know that production will be changing each year. And then our time horizon for the number of years that we'll be able to use this equipment. And then our capital investment, that initial upfront investment, and perhaps some salvage value at the end in present worth dollars, your interest rate, and then we'll determine this annualized capital recovery and an annual maintenance cost per year over that time horizon. And then kappa will be our non-recurring cost per part. So that's what we're going to use in determining our overall direct cost. So this is what it looks like. We'll annualize the cost using this capital recovery factor, add the interest on the salvage value, essentially what you would have made. So we end up with this expression here for capital recovery. You can see we've got the difference between the initial cost and that salvage value at the end. Here's the interest contribution over that time horizon. Again, N is our time horizon. And then this is our interest that we would have made on that value that is residual? Well, we can estimate based upon the type of maintenance we're performing, the cost of maintenance each year, and use our capital recovery factor and divide through by N sub j. N sub j again will give us the cost per part in that year. What about recurring cost? We tend to think of the recurring costs as being more expendable or consumable items. For instance, some tooling may be expendable, such as end mills, point tools, and so forth, that will have to be replaced in a shorter period of time. So we may end up making multiple purchases over the course of the year. It fits into this category if the lifetime of that resource is fairly short. And, of course, it can be as short as producing one part or on the order of months. So what we'd like to do is determine the life in terms of production volume and then spread the cost over each part as we did with the non-recurring costs. So examples, of course, tooling, testing material, anything that we have to purchase on an ongoing basis. We have a very simple model here. We'll have a useful life in terms of years. Typically that is going to be less than 1 for T sub L. And N, of course, is the production volume during T sub L. Beta will be the purchase cost of that particular item over T sub L, and then we'll calculate gamma, which will be the recurring cost per part. And then we can add that in with the non-recurring costs. So here's our cost model. We have gamma equals beta over N. Again, very simple. Spread beta over future production. And of course, as always, we would only consider present value of beta in terms of spreading that cost. So now we have a simple expression for the recurring costs in terms of cost per part. So our total cost per part is going to be the material plus the labor that we did last time, plus the resource costs in terms of recurring and non-recurring, and this gives us the total contribution of each of the elements of the direct costs. Now the question is, what do we do with our indirect and our overhead? Well, there are a variety of ways that we might think of allocating based on the cost, and that basis should be proportional to the amount of support that's required for that particular product that we're making. So for instance, if we decide that the basis will be on the percent of production, in other words, the percent of our capacity that we're using for that particular product, then that seems reasonable because it's telling us something about the proportion of that product that we are using other resources as well, such as material handling, line supervision, which would be indirect, any indirect materials, storage, as well as our infrastructure, the other category, the building, the taxes that we're paying, the utilities, and so forth. So many times what we'll do is lump together all the indirect, the MAT, and so forth, and create what we call an overhead rate. So we might have different types of overhead rates if we break it down at total overhead. By overhead, what we're saying is we'll take the direct cost times some percentage, and we'll add that cost to the direct cost to get our total cost. Now, overhead can be quite significant, and of course it will vary from industry to industry, but it would not be surprising to have on the order of 100% to 200% overhead. So that means essentially we're going to have a doubling or a tripling of the direct cost due to all the support that we need in order to produce that product. Don't forget, the direct cost is where we are adding value directly to the product. Well, we can break down this overhead rate, whatever it happens to be, and usually it's a signature of the products that we're producing. We could break it down into resources. How much do we need in terms of resources, in terms of labor, in terms of materials, and then apply the overheads to those specific categories based upon the direct costs that we've already calculated. So that might get us a little more accuracy in terms of this cost estimate. Again, you can see the component due to the overhead is a significant part of the cost, and that's why there's a lot of pressure to try and reduce overhead rates by reducing the need for support in terms of indirect and or mat costs. So at this point, you should understand the contribution of direct equipment costs, both non-recurring costs and recurring costs, and also the concept of an overhead rate that allows us to account for indirect other costs such as our infrastructure as well as mat costs. Equipment costs have to be spread out over all future production. The reason for that is we will be using the equipment, in other words, using up its useful life during the course of production, and therefore you are investing that amount of dollars into future production. So it's similar to the bonus where we were investing in terms of reducing the standard time. Here we are investing dollars in a direct adding of value to our product. The difference between non-recurring and recurring is the time horizon. So typically it's a number of years for the non-recurring, less than a year for the recurring costs. And for the recurring costs, it's much simpler. We're just going to use the present value of those items and divide by how much production occurred in that time horizon, versus the non-recurring costs, we use the capital recovery factor.